So, thank you all for coming. All right, we get to talk about some really cool stuff here today. So, my name is Eric Sdl. Oh, if my clicker works, my name is Eric Sdl. Give me a moment. And there we go. Okay. I have basically been working with compute and distributed compute and all sorts of distributed systems for many, many years. I actually have a background in distributed databases and hosting, Kubernetes, all those things. So that's the side I'm coming in from. I was a crypto enthusiast for a long time before I actually got hired here at Akash to basically meld two passions into one and have the coolest job ever without being a complete shill, right? So, okay, real quick, a ton of people in the audience. Have you guys had any experience with hosting, or what side are you coming in from? No hosting experience? Okay. No hosting experience. Awesome. So this will be very educational for you then, because essentially what we're going to do is we're going to take a look at the infrastructure that literally runs the internet, some of the problems with the old infrastructure, and some of the solutions that we're trying to provide here through open source, through the Akash network. So everything has a user. We're going to start from the user, and we're going to take a look from that perspective. The user here is just going to be our little stick figure, and this little stick figure wants to go deploy his website. Whatever that website is, doesn't really matter. They need to get compute. They need somewhere for that website to live. So traditionally, what that means is there's basically a small set of providers, generally, Glamazon, Microsoft, Toogle. There's some smaller ones. Digital Pond is there. But they're going to have to go and they're going to have to interact with those single providers, which are corporate entities, which they have to implicitly trust, or actually explicitly trust, if you really think about it. Because when they take out a lease or they deploy something on those providers, what ends up happening is they are giving control. They're actually giving physical access of whatever they deployed to that company. So how many people in here trust Amazon with your personal information without any protections? Anyone? Yeah, I'm not seeing any hands. So why would you take all of your corporate sensitive info, sometimes databases, sometimes user info, a whole lot of stuff. Why would you take that stuff, and why would you trust Amazon out of the box with all of those things? Why would you trust Microsoft, right? You have no reason to. And frankly, as history has shown, we probably shouldn't be trusting single providers. It's a single point of failure, right? So what do? We have providers, and we need lots of providers. We need ways to verify that these providers are going to be right for us. That's where a distributed network comes in. So users and providers, there can be many of each, and those relationships end up being stored on the blockchain. That's kind of the magic in a nutshell. If you get nothing else from my talk, understand that. We're basically storing these relationships, this contract for compute between a user and a provider on the blockchain, allowing for a decentralized hosting network. Really, really powerful, really, really cool. So let's take a look at this real quick. We got to establish a couple terms just so that we can all be speaking the same language here. First, container hosting. So on Akash, you're deploying containers. Containers are basically a lightweight, super efficient way to deploy an application. If you go to Amazon and you go get a server from Amazon, literally what you're doing is you're getting what's called a virtual machine, or a VM. That VM contains your application, anything else you've installed that application needs to run, and an entire operating system. Now you're paying for all that overhead, including that operating system that runs on that virtual machine. You actually have to pay for the compute for that to be up and running. In a container, it's a little bit different. The operating system lives underneath the container, and there's a container engine that shares the important components with those containers. So essentially, you're able to pay for your application and the things you need your application to as dependencies, the things you need in that container, and you don't have to pay for the operating system. You don't have to pay for any of that extra kind of overhead that is inherent to a traditional hosting solution. This is why the containerized revolution, if you've heard of Kubernetes before, this was the appeal of Kubernetes, is we can actually take these containers, these really lightweight things, we can distribute them and we can manage them. So essentially, we're taking that same concept and applying it on a much, much, much broader scale. Okay, how do these containers actually come into existence? Well, quite simply, there's a declarative recipe. Think of it like this. If you have a recipe, a cookbook, right, and you want to bake a cake, you can take a recipe out of that cookbook, you follow the instructions, and at the end of the road, you end up with a cake. Same exact thing here. There are declarative methods for each of these common containerization tools to end up with the container that you want. So in Kubernetes, there's declarative YAML. It's very, very common. If you actually search anything on Kubernetes, you're going to dive deep into YAML, which is a certain format of file. It's basically down a rabbit hole there. Docker, which was very, very popular, still is pretty popular, and Docker images are still in use in Kubernetes a lot, use Docker files. Docker Compose, which was kind of another layer on top of Docker for managing many containers, it used Docker Compose files. In Akash, we use something called Sdl files, which combined with an image, which we'll get into in a moment, create an entire deployment. So you can basically store the recipe for what you want up in the cloud in a file that you can just deploy as many times as you want and however you want, modify it, and we'll actually go through and do it. OK, Sdl file. It's really small up there, but that is a normal-looking Sdl file. We'll walk through the different parts here. You have your version, which isn't super important to us here. It's basically the version of Sdl so that we're all speaking the same language. The engine can understand what we've written. Version in this particular case, the modern version is 2.0. You have your image. Now, this is the important part. By the way, if anyone has questions throughout this, we've got a small room here. Raise your hands. We can have some back and forth. No worries. You have your container image. This is actually a Docker image. This actually pulls from the Docker repository. I believe this particular one, this particular one is one that our company has provided, just as a free access. Anyone here ever used Pastebin back in the day? Basically, you would paste a large block of something, send that link to someone else, and they could just copy it back out without having to have any sign-in or anything like that. Essentially, the Sdl file we're going through here is that application. So, all right, so you got your container image. That's the actual process that's running. You've got your network and ports. Now, if you're not technical, that's not going to mean much to you. If you are technical, this is basically how you keep things secure. You only want to expose access to the things you want to give access to. Otherwise, someone could come in, mess with your computer, take down your compute, bad stuff. So that's basically security stuff. Next, we've got our service type. Now, the service type is really important. You'll notice here that we actually have that goosebin there, and we also have that Redis there. Those are our service definitions. We're basically defining those. Those are arbitrary. I could name it pretty much anything. I could name it web front end and database. I can name it whatever I need to name it. But that's arbitrary, and I'm going to use those names later on to bind those services to the actual physical compute that I'm going to be deploying. We'll go through that. OK, so now we actually get into the part that's the recipe for the compute we're going to use, or the computer, the box that we need to run this application. We're going to define that. So what we have here, you'll notice we actually have a fraction of a CPU core. That's one of the cool advantages of using a container is you don't have to get a whole CPU, right? In a VM, you would actually have to go out and say, OK, I need this many cores, and then you basically get allotted a certain number of cores. This way, you can actually share a core if you don't have a heavy lift. It's a great way to save some money. So in this particular case, we're taking 1/10 of a CPU core. We're taking, let's see, that's an 1/8 gig of RAM for memory. And we're taking an 1/8 gig of storage. And we're assigning that to that profile of web right there. That is what's basically giving us a compute definition. Or if you think about it in a recipe, we are defining the length of time we're having to cook for, the order of ingredients we're adding, all of those things. That's basically what we're doing here. So we're doing the same exact thing for the storage profile. You'll notice there we actually have more RAM. Pretty much everything else is the same there. But in order to run Redis, anyone here who's ever touched Redis knows, you're going to need a little more than an 1/8 of a gig of memory. So we're accounting for that in our Sdl file, and we're creating this storage profile. Next, we have to tell them, or to tell the network how much we are willing to pay. And if we want a particular kind of provider, if there's something we're looking for is very specific. So that's where this comes in. This is the placement. Literally, you can think of it as where do we want our container to be placed on the network. In the first part there, we have some what are called audited attributes. And we'll get into those in a minute. But basically, that's how you can define who you want to actually host what you have. So If you want something that's only trusted by a certain group of people and they've signed something as trusted, you can go in and say, I only want to use those trusted resources. Next, we have the max amount you're willing to pay per block. So in this case, it's actually a very high number. That's 3,000 UAKT per block. That's so because we want to get a large bid list, and we want to be able to pick through those and figure out which compute we actually want to work with here. So we have our web profile and our storage profile. We've defined how much we're willing to pay for each of those two resources, as they are different resources. Next, this is the magic part. This is where we tie all those different pieces together and make it work. So we have our service, their goosebin, as we defined earlier, and we tie it to a profile. So we basically say goosebin is going to use that web profile that we defined. So when we actually spin this up, it's going to take those same configuration parameters we had from before, and it's going to put the goosebin image, remember that image, that Docker image, it's going to put that on compute that reflects what we have here. Same thing for the Redis. It's pretty much no difference there. So it's going to take a ½ gig as opposed to what we were using on the other image, half gig of RAM, and it's going to put Redis on a slightly larger box that Redis needs to run. OK, so that's the boring part. I promise we're through that. We're going to get on to the good stuff. So container definitions, simply put, turn into containers. If you have a user has an Sdl file, user needs to go out and get some compute. So what they're going to do is they're going to take that Sdl file, and if you remember that placement portion of the Sdl file, they use that to create a bid. And that bid goes on blockchain. It actually goes on chain. And what happens is providers are watching the chain for these bids to come through. Now, when the provider sees one of these bids or bid requests hit chain, they go and they submit bids, if applicable. So if you had put a filter on there, for example, maybe a particular attribute you were looking for on a provider, or maybe there was a certain cost you were trying to meet, and that provider doesn't meet those criteria, it will not submit a bid on that request. So those bids go on chain as well. Next, the user goes and selects one of those bids. And once you've selected a bid, there's a piece of this that has to go on where there's an escrow, right? Because basically, the provider has to be guaranteed that they're going to get paid for the compute that you're using, right? You won't want someone standing up a website and before the pay date pulling it down and cutting all ties and canceling the transactions. You won't want that happening. So there's an escrow. So what you do is you submit your lease, which reserves those resources, and you submit your escrow, which is just done in the crypto, it's done in AKT token. And that basically guarantees your place on that particular provider. So the SDL, then, we're going to take and send to that provider. Because you remember, we have all that definition in there of the images we want, of the services we want to set up, how we want the whole thing organized. We're going to send that SDL to the provider just over HTTP. Now, if you're not too familiar with web protocols, HTTP and HTTPS are literally the language of the web. That's how websites talk. HTTP is what your browser reads. It's what most of the services on your phone, if you look at the different services when you're clicking buttons, generally speaking, they're sending HTTP requests to an endpoint somewhere, and that's sending information back. We're doing exactly the same thing. We're speaking the native language of the web to send an SDL file to a provider, and once that provider has the SDL file, they turn it into a container, right? Because it's a recipe. They bake the cake for you. So that user now has a running functional website up on a provider that they've been able to select, that they've been able to basically go through a bid process to actually acquire something that meets their needs, and nothing more than what meets their needs. Again, that's one of the big problems with Amazon, right? When you go there and you buy compute, you have to buy way more than you need because they come in these predefined chunks, and you can't really break out of that cycle. So here, this user got exactly what they wanted. They're only paying for what they want, which you might have heard that Akash is, there are a lot of different numbers out there, but it's generally in the 3 to 10x range cheaper than Amazon for the same sort of workloads. Reason is because you're not paying for things you're not using. You don't have that OS overhead for the operating system to be running on the stuff you're paying for. You don't have to buy 20 cores if you need a lot of memory, but you don't need a lot of cores. You just configure it to reflect what you need. OK, so from the provider side, this gets a little technical again, but I'll try to keep it simple overall. Kubernetes is the back-end container engine that we use by and large today. Kubernetes just manages containers. That's all it does. It orchestrates things, makes sure that they stay online, that they're managed. Basically, it's just a giant bucket we throw all the containers into, and it makes sure they stay alive. Now, our container can live right alongside a whole lot of other containers. So when a provider, say a large provider is out there, and they are accepting bids, it's not a one-to-one relationship. It's a one-to-many. Many users can run containers on a single provider as long as that provider provides adequate resources. So providers could be as big or small as they want to be, essentially. They could maybe be in a situation where they don't have a ton of high-end hardware, and they just have a very small cluster. Maybe they only have 2 or 3 websites that run on them. Totally fine. Again, this is peer-to-peer, right? We're basically Airbnb for compute, if you think about it that way. OK. Now, I talked about a little bit about security right up front and how we have this way of filtering off of certain attributes what you want to get to. Let's dive into that a little bit. So in a network like Akash, there are a lot of providers. And that provider could be anyone. It could be maybe a big provider. Like maybe Amazon comes and decides to be a provider on Akash. Wouldn't that be kind of cool? Or maybe it's someone in their garage who has a ton of old server hardware that they've acquired, and they just trying to earn a little money with it. Or maybe it's someone with a cluster of Raspberry Pis, and they're sitting there doing a project, and they're trying to be a provider. You'd have no real way of knowing without some mechanism for querying. So that's where this thing called audited attributes comes in. Now, audited attributes are kind of arbitrary, but stick with me here. You'll get the hang of it in a moment. I'm going to use the completely fake artificial attribute of trusted is true. Okay? So from my perspective, I've gone out there and I've vetted some providers. I've said, OK, these providers, I like what they're doing. They have some good, maybe they have some security compliance stuff that I care about. So I'm going to mark them as trusted equals true. Now, anyone can query what I marked them as. So if someone else were to go out and say, I just want servers that have trusted attribute equals true, they'd get everything I marked. Right? This is decentralized blockchain. This stuff all basically goes pretty public. So how do they, as a individual, make sure that they care about the same things I care about, or that I'm not a bad actor, right? Because I could be a bad actor, and I could be marking maybe malicious providers as true, and then you, as a user, come in and query what's trusted, and then I've got you on my malicious providers. Well, that's where this thing called audited attributes comes in, the signing. So who signed? You can actually query who signed, and that attribute, when I sign it as trusted equals true, there are 2 things that happen. Number 1, it signs it trusted equals true. That's pretty good, right? The other thing is it puts my signature, or in this case, a overclock's signature on that attribute. So essentially, you can query who set up that attribute as true. And so now, if we think about it from a decentralized standpoint, right, you don't necessarily want us here at Overclock, at Akash, saying, hey, we think these providers are good and those ones aren't. We want it to be decentralized. So there could be community members who basically go out there and verify resources, like trusted community members who go out there and they're basically doing audits, they're doing pen tests. Maybe they're working directly with providers, and they are now signing things as this is a trusted resource, or this has this compliance, or whatever it is that you care about. They could be signing providers, and you could query off of basically who signed and check if they have signed the providers with the things you want. So from that, we're able to create a distributed masterless system where trust is established. So very, very key, very, very important. Kind of the secret sauce that holds this whole thing together, if you think about it, because relationships are built on trust, and you need to provide trust, especially in this crazy decentralized world. OK, so all of that is actually stored in the Sdl file. So under that placement part, you notice originally it said signed by, and then it had basically a wallet address. This is exactly what it was. So you can put the attributes you care about. So in this particular case, we're filtering off of trusted equals true. And you can take the wallet ID of the person that you want to trust, and boom, you're good to go. You're off to the races. OK, so all of this is still goes into that bidding process. If someone doesn't meet those audited attributes you have, they won't reply to bids even. The network won't allow them to. They have to be marked with the right things by the right people, and you can filter on that. Therefore, making it even further secure, because you're not having to filter on those things yourself, they're not going to be replying to bids, and the network won't let them reply to bids unless they have the correct attributes. All right. So putting this all together, we have this giant decentralized hodgepodge of providers and users that's wonderful, where our containers from users can run on these providers. All these relationships, all of this audit trail is on the blockchain so that we don't have to care as individuals about the who has my data. It's all there, it's all queryable, and you know what? If I don't want to put in an email address or swipe a credit card, or maybe I live somewhere where that's not even possible, if it's a country that I don't have access to those sort of financial resources to actually get a credit card, I can now have a crypto address, and that's all I need to actually get compute. Really, really powerful. Okay, we're going to do a bit of hands-on now. If you have a laptop, feel free to pull it out. This is going to be interactive, so please, if you run into a problem, raise your hand. We have a couple people here who are basically going to run around and help put out any fires that might occur. So, all right. Let's see here. So we're just going to go over to Firefox. Now, the first thing I'm going to show you here is actually a browser extension. This is Kepler Wallet. Has anyone here used Kepler Wallet? Oh, yeah, a bunch of you. OK, cool. Yeah, Kepler Wallet is basically just kind of a Cosmos wallet. It's actually a really nifty browser extension. So let's do Kepler. And I'm going to go ahead and I'm going to install that. That's a good first step, right? So Chrome, got it. Boom. It wants me to do it in Chrome, because I did it in Chrome. I had the wrong link up. Kepler Firefox. OK. There's no Firefox Kepler? Now you know I tested in Brave earlier. So I'm just going to go over to Brave. All right, so when you're in Kepler, it's basically going to be a browser extension. It's going to look something like this. And the browser extension is just it's just a wallet. Now, if you have a ledger or something, a physical wallet that you want to secure with, Kepler actually integrates with that, which is really, really handy. We're not going to be using one of those here today because we're trying to get some ease of use. So I'm just going to show you basically what goes into it. Now, if you're following along, which I don't see anyone with their laptop out, so I'm just going to kind of roll here. If you're following along, you could go and you can actually use your Gmail address to create that Kepler wallet, and everything's tied there. They'll actually email the mnemonic, and then you're basically off to the races. That's fine. The important part is this. This is the deploy tool. So traditionally, back in the dark days, we had a command line interface, and you basically had to go into a Linux terminal to actually deploy anything. Now we actually have UIs, and these are actually contributed by the community as part of the open source project. So this particular one was made by a community member named Space Potato, and we're going to go ahead and we're going to use it to deploy an Sdl file. Now that same Sdl file from earlier, I actually have here. And if anyone's interested, I can give you the links. Colin actually can also provide those for anyone here. But essentially what we're going to do is we're going to copy this Sdl file, which again is the recipe. This is the recipe to bake the cake. So I'm going to go ahead and, oops, use two hands because it's easier with two hands. There we go. And I am going to copy this Sdl into the window here. Now, you'll notice I have my I have some AKT in this account. That's literally just what I have in Kepler. With this particular interface, it actually integrates with Kepler, so it looks if there's a Kepler wallet there, and it basically will ask you to authorize a connection. You authorize a connection, and you're good to go. So, OK. So I have my Sdl there. I'm going to hit deploy. Now watch this. I don't know if you all can see it. It's pretty small up there, but we have this red text that's going to scroll through all of these different steps I laid out. And it's going to basically let you know what's going on here. So I'm going to approve the transaction, like you need to do for security. It says waiting for bids. So it's put that lease request, or the bid request, up on the blockchain, and it's now waiting for providers to get back and say, yes, we have bids. Generally doesn't take very long. Could take maybe up to 2 minutes, but oh, there we go, perfect. So these are a list of providers. Now, there are, if you want to go get more info on these providers, you can actually get a lot through the command line tool. Currently, with these UIs, like I said, they're community contributions. We're actually working with community members to help flesh out some of these features a little more. But this is very functional. And I happen to know that this address right here is one I trust. So I am going to go ahead, and I'm going to select that one right there. That is the provider that I would like to work with. And I'm going to hit submit. Now, it's going to ask me again to approve. and it says awaiting create lease transaction. So there's actually a transaction that's going against the blockchain right now. If you remember when that lease and escrow step was in my PowerPoint, that's what's happening right now. We've got that lease that's created, and we've got that escrow is being put up there, and this whole thing is happening automatically. I'm not having to type out every step. It's actually really, really simple. All right, querying lease status, and boom, we're online. OK, so I've got a URL here, and I'm going to go ahead, and I'm going to go to that URL. And now, you remember how I said this is just a copy-paste tool? This is like Pastebin. I'm going to create a new paste. And we're just going to type in some nonsense, create a paste. Now, anyone can go to that particular address right here on Goosebin, and it will bring up that same little block of text I have there. Now, why is this cool? All right, what I just did, has anyone here heard of microservices architecture? It's kind of like all the rage about 3 years ago. Everyone was talking microservices, microservices. This is what we have to move to. That's actually what I just deployed there. I have 2 different servers running. Well, one is a supporting service. One is basically a front-end service. And I just deployed that from a single file. If I want to make a change to this deployment, or if I want to go spin up this deployment on a different provider, I'm going to take that SDL, make whatever change I wanted, or take it to a new provider, take out a new lease, boom, I have a second website. That's censorship resistance. Because if somehow I were doing something that maybe didn't sit well, maybe I'm a journalist and I'm in a nation that is in turmoil and the government doesn't really like my opinions or viewpoints, right? They might try to shut me down. If somehow they got to that provider and managed to shut me down, I could hit deploy again. Everything's in that SDL. That recipe's there. How are they going to take me down when I can just take out a new lease? OK, you took me down for 2 minutes. Big whoop. I'm back up and online. That's censorship resistance. That's pretty cool. That's one of the reasons why this is probably, if you haven't guessed already, the future. We are moving to a world where basically Web3 is going to allow anyone to have access to the resources, whether or not they can get resources from a financial institution, whether or not they can get a visa, they're going to be able to get access to compute resources, which are very important for any business in the modern world. That's like the cool factor. Hopefully someone's mind was just blown there. All right. Making good time here. So we're going to go to the last place. Please do get involved if you're at all interested. Colin's up here. I'm up here. We've got Greg. We've got actually a few Akashians in the house here. Come talk to us. Check out our forum. Check out our website. You can play with this stuff. This is all actually open source too. If you're kind of a code monkey and you want to actually dive in, everything, the whole Akash, everything is up on GitHub. So we can get you links for that. And yeah, that's pretty much it. Right.
So people are likely to stream or to post malicious content.
Yep.
I know this is censorship resistance. So I guess what's the idea behind that, right? Because you can't have
Right.
thing with malicious content.
Right. What if terrorists or child porn or any of those really horrible things are happening?
Anything you want to think of.
Yeah.
So what do you do with that?
Yeah. So that's actually basically on the providers. Oh, sorry. Yeah, absolutely. So the question was, if someone's basically using this nice censorship resistance to shield themselves from basically justice when it comes to hosting a really, really malicious workload. So something really bad like child porn or violence of a horrible nature, right? How is that handled? Well, that basically comes down to a provider. So a provider, just like in the normal world with the big companies, right, how we have to trust them because they can basically see what we're doing. The same thing is true here. You're just able to select the provider. So that provider could identify that workload and shut them down. If they could obviously open up a new lease, and there'd be no way to stop that. But the providers can basically go through and manage those workloads. And a responsible provider would. So does that answer the question? Greg, do you have anything you want to add?
Right. So the idea is as long as the provider The idea is, as long as the provider is willing to host your workload will run. So something terrible like child pornography, you assume no provider wants to host it. But if it's something that's politically misaligned, there might be some providers who want to host it. So it's the position we take is a very neutral position in terms of censorship and moderation. And the position is, freedom of speech doesn't guarantee you the right to yell fire in a theater, right? So that's really where we're coming from. Yeah, but ultimately, provider's liable. Like whoever hosts the workload is liable, right? From a liability standpoint.
What if you have a malicious provider who is hosting this malicious?
Yeah, then there's nothing you can do about it, right?
Well, it would be.
There's an IP address, I suppose. Authorities will track down, but yeah.
Yeah, providers are actually the easy ones to take down in this situation. The onus is on them, essentially. Yeah. Yeah. Any other questions?
Yeah, I've got a question.
Yeah.
How long does the lease last for?
Yeah, so the question was, how long does the lease last for?
Yeah, I didn't see a place where I didn't see a place where you configured how long you wanted your service to run for, or how long they would guarantee your service for, or what have you.
Right. Yeah, so that's where actually escrow account comes in, because escrow essentially is a piggy bank that goes down to 0. When it hits 0, your lease is up. You can add more to the escrow account. So the escrow account is kind of the mechanism for that. The default, actually, it just changed in it. Prop 12 passed in it, I think. So previously to a thing that just passed from a distributed governance standpoint, it was 5 AKT would be put into an escrow account by default. And that would just, again, burn down until it was 0, and you'd have to either put in more or the lease would expire. I don't know what the new number is after Prop 12 passing, but it's lower at this point. Yeah.
And you're paying on a per block basis,
Yeah.
not
Yeah.
per transaction.
Right. And that actually I can show you here. Let me find it. So, yeah, you're paying per block. So the UAKT, obviously being a very, very, very tiny unit of AKT, the actual amount you're paying here is how many per block. So generally it would be like 4 or 5 would be a typical lease for, like my deployment here would not even come close to 3,000 UAKT. But
And from a replica standpoint, do each of the replicas, can you choose a different provider for each of your replicas?
so like hybrid cloud kind of
Yeah.
concept?
Yeah,
Yeah,
exactly.
I don't know any reason why you couldn't, yeah.
So you'd get a bid back for each of the replicas, and you'd select multiple bids potentially. Okay.
It's highly composable, the Sdl file. Mix and
Yeah.
match any provider anywhere.
Yeah. And you could even run different resources on one versus another if you wanted to. Like,
The other way to look at it is glorified multi-cloud deployment.
yeah. Yeah, it's like native multi-cloud if that's, I don't even think that's a thing yet. We can make the buzzword popular. But yeah, any other questions? Okay. Well, awesome. Well, thank you all for coming.